Chapter 10, Chi-square. What is the chi-square? A chi-square is a statistical hypothesis test that uses bivariate tables to determine whether or not a relationship exists between variables. It is one of the most commonly used hypothesis tests in social science because the assumptions that need to be made in step 1 of the 5-step hypothesis test are very easy to satisfy. The reasons for this are: the test can be used for any level of measurement, ordinal, nominal, interval ratio. The test is also non-parametric or distribution-free, and therefore requires no assumptions about the shape of the distribution. Before we give an example and go through the 5 steps of the hypothesis test with the chi-square, certain aspects of it must be explored. Although the chi-square can be used for any level of measurement, it is best used with nominal variables. The null hypothesis for a chi-square states that there is no relationship between the variables and that they are independent of each other. Further, any statistical relationship occurs by pure chance. Now let's jaunter through the 5-step hypothesis test using a chi-square. Step 1. Making assumptions and meeting test requirements. As previously mentioned, no assumptions are made in regards to the shape of the distribution. The model consists of multiple independent random samples, and the level of measurement can be ordinal, interval ratio, or nominal. Step 2. Stating the null hypothesis. The null hypothesis states that the two variables being tested are completely independent. If the null is true, the differences between the observed and expected frequencies will be small. As with all other statistical hypothesis tests, the null directly contradicts the research hypothesis. Step 3. Selecting the sampling distribution and establishing the critical region. Establishing the critical region for a chi-square is similar to establishing a Z or T critical. It requires 2 steps. You must first establish your alpha level, which is generally considered 0.05. Second, you must establish the degrees of freedom with the bivariate table using the formula C-1 times R-1, which would equal the degrees of freedom. The alpha level converted to a confidence interval and degree of freedom gives you the critical region by using Appendix C. For example, if the confidence interval is 0.95 and the degree of freedom is 4, then the chi-square critical will be 0.711.